Hello, welcome to our talk, Crossplane as your platform API. Our decision, scars, and the V2 upgrade want to cover today. Before we start, some words about us. I think you can start.
Yeah, I'm Stephan Hüttner. I'm head of platform engineering and cloud solution architect at WhiteDuck.
Yeah, and I'm Philip. I'm also a cloud solutions architect, and our daily work is mostly on Azure, as we're Azure MVP. And we're doing everything around Kubernetes, automation, DevOps, platform engineering, what you call it. And before we also start, a little bit agenda. So we want to talk about a little bit the platform problem, what we had when we implemented our API platform, our decision path, why we decided something and how, what was the process. Then we want to talk about our cross-plane control plane pattern. Then we have the scars and validation recommendations, or what we discovered during our journey. Then a little bit we talk about observability, and then we go in the cross-plane V2 migration. And if we have time, we can also do some question and answers.
So, the platform problem. I give a small intro to the customer, not the customer, I won't tell you the customer, but large company came to us, I think 1.5 years ago, and they asked us, can you help us build a platform? And so we say, okay, our daily business, how can we help you? Or what do you want to accomplish? And then they told us that they migrate from ServiceNow ITSM to another ITSM system. Also, as you may know, there's over the years, a lot of business logic put into ServiceNow. And then they said, okay, we have to cut this out. We want to deploy this in a more platform-agnostic way. And it should be containerized, it should be Kubernetes, and it should be self-service, almost self-service. So the devs get a repo, they can start implementing right away and deploy their workloads to the Kubernetes cluster. But they should also be enabled to provision their infrastructure. So if they need a storage account or a database, they could just deploy it on themselves. All right. Then I go to the next slide. So yeah, and it shouldn't be a portal, so it should be more low level on the code base. So the first instinct when we think about provisioning infrastructure, Terraform. So but then we thought about, okay, the devs, they don't know much about Kubernetes, they don't know much about GitOps, they don't know much about Helm charts. So we didn't want to put another burden and learn Terraform. And it would have been a multi-step process, because then you have to first deploy your infrastructure, then you have to get your connection strings, whatever, and have to put it in your config maps, or you have to go to a key vault and then pull it from there to a secret, Kubernetes secret. So we thought we do it more in a Kubernetes cloud native way, and how we ended up, this will tell you Phil.
Yep. So our final decision, then I will show a small architecture that you have a brief overview. So as we are like huge Terraform fanboys, so we wanted to stick with the base platform with Terraform, because in our thinking is the base infrastructure, we will show you later, is a little bit more static. So we don't need this cross-plane recognition loops all the time. So we deploy the base infrastructure with Terraform. And then we looked at other solutions, like for example, as we're on Azure, there's the Azure Service Operator, but the Azure Service Operator is more like not a product API, so it focuses mainly on the Azure cloud resources. And what we want is not that the developers think, and I need a storage account, I need a disk. So they want to come to us and say, I need storage, the rest doesn't matter. Or I need telemetry, and it doesn't matter what it is on Azure. So that's why we didn't go the way with the cloud-specific operators like ASO. And then we looked at Crow, but at this time, Crow was not mature enough to meet our needs. As of now, I think they have a little bit the same philosophy and concepts. So if we would do it now, we would definitely, or I recommend to you, look more into Crow and not in only Crossplane, and check what it needs for you. But at this time, Crow was not an option. And also on the page, they said like it's not ready for production use, right? It was 1.5 years ago, so that was our thing. And then we choose Crossplane because it gives us custom resource definition, composite resource definitions, composite GitOps fit because we wanted to go the GitOps way, yeah? And also we wanted to leverage Kubernetes, so we have the same API interface for us, for the developers, yeah? But the thing is, like always, decisions comes also with downsides. So the complexity is it's not more like an infrastructure, but the complexity shifted into the API of Kubernetes and validate all of the resources from Crossplane, right? But we will cover it a little bit later. And this is a bit roughly the infrastructure, how we ended it up. It's just like there's 3 environments, so we don't edit the environments, but as you can see, it's like 2 ownership paths, let's say. We have the platform-owned path, which is the base Terraform infrastructure, the base Azure infrastructure, the Kubernetes cluster, right? And the platform GitOps repo, where we have all the resources from Crossplane, so the composite resource definitions, the composition, our functions for the customers, lives all in the upper path, platform-owned path. And then we onboard the use cases. We call it use cases. And this, so one use case is one application. So we in the middle you can see. I don't know. I don't have a pointer. I think. Oh, I have a pointer. I have a pointer here. This is like the onboarding of the use case repos. And then in this use case repos, which are owned by the application teams, we say, hey, put all your things in the GitOps directory, and then we will synchronize it into the cluster. That's basically the idea. And from there, we have 2 paths from the use case repo. We have the application path. It's a blueprint Helm chart. Doesn't matter for now. And the infrastructure part with Crossplane. And the Azure resources came out. So the use case, the application developers have everything they need. There's a special case with the API workloads. So if there's API workloads in this use case, the customer has a little bit cross-tenant Azure setup. So it's called like multi-tenant app registrations. So this is a little bit a special use case where we validate JVT tokens across multiple tenants. Yeah. It's a little bit special setup. Stephan will cover it when we talk about the claims. And think of this architecture as Crossplane v1, right? Because where the application team uses still the claims. And we will cover v2 later. Okay, then let's go to the control plane pattern of you.
Okay, thank you. Yes. So this is how we set up the control plane pattern, and it's a bit of a 101 cross-plane, but also it's how we set it up so that we get all the data we need to deploy the infrastructure. So this is a small snippet here. This is how the claim looked like. As I said, this was v1. This is, if you know Azure, it's an application insights. And as you may know, you need a log analytics workspace, so you need 2 resources, the log analytics workspace and the application insights itself. And you would just have the snippet, the dev put it in their namespace in the GitOps folder, and then they get both resources, and they also get a secret written to this name. They can choose it, and there's the instrumentation key they can put into their applications or mount it in there. And with all this, with this small snippet, you get the naming, the identity, the RBAC policy, and exactly the resources. And the devs don't have to add anything like a resource group, no subscription, no tenant IDs, nothing. So really easy for the developers. So how do we get to this point that we deploy to the right resource group and the right subscription? So there are 2 things. The main thing is the XRD. So the XRD is like a CRD. It's a composite resource definition. So it's how Crossplane named it. And it's similar to a CRD. So you have an open API spec, and then you define your API there, what you want to offer for your product API, what you want that the devs can set. So don't just mirror like every parameter. Think about it, because changing this later is a pain. Exactly. And you can also add, so you set an API group that can you choose, of your choose. You can take the company name, and then you set a kind and the plural. And for v1, you also, if you wanted to use claims, then you had to set the claim name. Exactly. And then you can set also a status. So you can, when you later come to the composition, you can also set data to the status, and then the dev can see in the claim or in the composite resource the status. And the second one, this is where then the resource group and everything comes from. This is platform owned. This is set by us. So when we onboard a new use case through GitOps, we create the namespace, and then we create an environment config. This is a specific resource from Crossplane. It's like a config map, you could say. And it's strongly typed. So you can set there, we set there the subscription ID, the resource group, the tenant, tags, for example. Yeah, and when you have managed identities, the client ID or anything like this. So, and when this is there, then this goes, I don't know how deep you are into Crossplane, then this comes to the composition pipeline. This is then, I come in the next slide, this is then where the logic happens, the magic, and then there we read the environment config, and then we get the managed resources. These are then the cloud representation of the cloud resources. And you can also use the environment config if you validate locally. Then you can also, with the Crossplane CLI, can also give this context, like an example environment config, and can test this in pipeline or locally. Okay, so this is the compositions. This is where all the magic happens. This is where the logic you put in. And there are a lot of options. So a composition is like the template. So you have it's a pipeline, and it's a function pipeline. So you can chain multiple functions, and they give the context from one function to the other function. And they get as input the XRD, the parameters. So the first, that's not here listed, the first function we always use is the environment config function, because this is what we need. So we put this first, and then it gets, we select it by the label. The environment config has the same name as the namespace from the use case, and then we get the context from all the data from the environment config. And then we have, these are the three that we used. So there are multiple options you can use. There's the Python function, there's a KCL function, Pythonic, there are multiple functions you can choose of your choosing. But the first one is the one I think everybody starts with. It's the patch and transform function. It's a really basic function where you just can, like the name says, patch and transform. So it has also a lot of limitations, so it's more for static resources. Like I said, the application insights, you know you need a log analytics workspace and an app insights, so it's always the same. So then you can, for example, it's a good fit for the patch and transform function. But if you have multiple resources, then it can get messy really fast, because you have to chain it underway. And if you need data from one managed resource in another resource, then you have to patch it first to the status of the composite resource and get it back then in the second resource. So it's, as I said, it's messy. And the other thing is it has a lot of limitations, so you can't really iterate. So you can't say, okay, give me 0 or more, whatever, blob containers. So this is not possible with this function. And what's not possible is conditioning, so real conditions, so that you can say complex, if this is true and this is false and whatever the string is, then create me this resource. This is also not possible. So if you have basic stuff, then it's good to choose this. But we came to limitations really fast, because the storage account, for example, we wanted to offer, so the dev could choose, do I need 10 tables in my storage account or 5 blob containers? Then we came to the limits here. And then we chose the Go templating function. So the Go templating function, everybody knows it. It's like the same in Helm charts used, so we love it all. And this is where you can do loops, lists, and conditionals. So this is our go-to function. We use this for almost everything. And if it gets really complex, like Phil told you, the customer has 3 Entra ID tenants, and we have to create app registrations, and it's multi-tenancy, and a lot of stuff is happening with IDs, with object IDs and tenant IDs. And we tried it with Go templating, but it was a mess. So it was so much Go templating code that we chose to build our own function. And there you can do what you want. So, but that has also a lot of drawbacks. Phil will tell you about this. All right. And so here's a nice overview. So you have the claim, now it's gone in V2. Then you have the composite resource. And in the composite resource, you have a claim ref, you know the namespace. And from this, we can choose the right environment config. And then we have all the context we need and can, with the composition, build the managed resources. All right. Now
okay.
it's your part.
Let's go on. We have to speed
You
up.
have 9 minutes.
Yes, sorry. Yes, and let's go to the scars we discovered in our journey. The first one is like put logic in crossplane primitives, because you have like 3 layers. It's the XRD contract, the composition pipeline, and the function code. So the XRD contract is for validation, because it's open RB scheme, right? The composition pipeline is for orchestrating all the resources in the cluster, and the function is like, you can think about it like dynamic runtime logic, which also leads live data. For example, if you compose names in it. The thing is like, if you think about it like this, if you do dynamic naming of resources, let's go back to the Azure storage account, because it's a good example. If you dynamically create a name, and it has a limit of 24 characters in Azure, if you do it in a function code and the user do a mistake, because they can add a suffix, and if it's too long, all your layers run through, and the user will get no feedback, because everything runs through in Crossplane, but the resource is never provisioned, right? Because the naming is at the end, in the object, in the managed resource, will get an error, but the user did not see it directly. So you have to wait till all these steps go through, and that's like a big mistake. So what we discovered, or which rule we follow now, is like use the earliest layer that gives you useful feedback. And that's basically, in this example, would be the XRD contract, so the composite resource definition, where you can limit the characters to 24. Then, if the user did a mistake, they would directly at the apply level, he would get the error message. Second one, because I have to speed up, is custom Go functions are software products. They need, as Stephan wrote, we wrote a complex Go function for do some stuff. And you don't see it as a config file in your cluster or in your repository. Yeah, it's like a real software product. It needs CI, it needs reassemblement, and especially it needs ownership, because nobody is the owner of the software product. It will rot in your cluster, and at the end, it's not good. And the learning we have, so you need an owner, and a custom Go function is only worth where complexity is really high and patch and transform doesn't work for you. Yeah. Third one is also good example. Does any one of you use GitOps? Okay, did anyone, but be honest, deleted a namespace and thought, it's coming anyway back because of GitOps? Some. So we also did it, but we did not think about that on default behavior of Crossplane is to delete the managed resource. So we nuke the database, basically. So this we learned in the hard way. So the rule is like always, before you do something, like test, create, or do the whole life cycle, right, of your compositions. And use management policy and remove the delete feature, especially for managed resources like databases and storage. And as we talked before, that the complexity will shift a little bit. What you need if you do Crossplane and our setup, you need good validation everywhere. Yeah? So only YAML parsing is not enough. Yeah? We need to render the compositions in the pipeline. We need to run in every repo. We need PRs, right? We need validation. We need rendering. We need schema validation. Yeah? I'll skip a little bit to our recommendations. So for platform PRs, we validate the custom resource definitions, the composite resource definitions. We render everything with real functions. We use Crossplane resource validate. Yeah? And at the end, in the use case PR, we do the same. So we have also like a 4-layer principle where we validate the flux if the GitOps layer is healthy. Yeah? We validate the Crossplane resources. At the end, we do the server-side dry run on the cluster to see if the resources will be provisioned. Check. And observability, also a good layer. We build around Crossplane. I mean, it's also a little bit V1 and V2, so you have to be a little bit careful, but this is more like V1. So you have basic conditions, ready, synced, responsive of your resources. If it's synced false, it's not there, right? Ready false. So you have to monitor these Crossplane conditions. And if you go to debugging, always go for events first in Kubernetes because the events are human readable, right? And then you go on to the Crossplane logs, to the provider logs, and the function logs, like in this order, to drill down all your issues. And also Crossplane has a mighty command is Crossplane resource trace, where you can monitor the whole tree, the composite resource, and so on for your monitoring for your logs. And everything Crossplane is like cloud native. It's like nothing custom here. So you just enable all the metrics in the Helm chart. You can build dashboards on the metrics, right? And in version 2, they use the circuit breaker matrix now, which is monitor the reconciliation and gives you metrics about that. I have to hurry up a little bit. So Crossplane V2, Stephan?
Yep, 4 minutes to upgrade.
Yeah, we have 10.
So just to be quick a bit, so the main thing that happened in Crossplane V2 is that they removed the claim. So as you may know, if you know Crossplane, the claim, I think it's the only resource in V1 that's namespace scoped. The rest is all cluster scoped. So they changed this model completely, and now you can say, okay, I want my composite resource namespace, I want my managed resource namespace, my provider config can be namespaced, everything can be namespaced. Namespace scope.
So the problem is that you always have to give the user full cluster access to see the resources because they are not namespaced. That was the reason. That's the reason to the upgrade is really worth it, right?
Yeah. So when you upgrade to V2, you get legacy compatibility, so it's not a problem to upgrade. There's also now a command, I think a migrate command in the CLI from Crossplane 1, that you can check your cluster if you have anything that was removed in the V2. So for example, the controller config, I think is removed. You need now to migrate to the deployment runtime config. And if everything is good, then you're ready to go. You can upgrade the control plane, so Crossplane itself, and you will get a legacy compatibility, so nothing big changes. So I have to correct this quickly. Phase 1 is really easy, as I said. You check with the CLI, can I upgrade? Is everything okay? And then you have to go you have to upgrade to the latest version of 1.20. Then you go to V2. And then every minor step. So it's a it's a requirement. It's also in the migration guide of Crossplane. And every time you upgrade, wait a while because all the providers at some steps they will restart. It takes a while, and it will be all the XRDs will be converted to the new format. So then your legacy XRDs will have the scope legacy cluster, but they're still working the same. You can use your claims, everything. Exactly. Now we go to the really fun part. This is when you want to move to the new model, to the new resource model. So we did it. This is the way we did it. There are multiple ways, but this is a good way to do it. It's a bit tedious process because a lot of PRs and rethinking is needed. The first thing we did is we just did a copy of the XRD and the compositions, and created a new API group. So whatever, you have an API group, and then you do a V2 or whatever. And then you set the scope to a namespace, so you have to set the scope. And the other thing is, then you have to, in the composition, you have to set all your managed resources to the new provider namespace API group. So there also, the spec is exactly the same, at least it's for the Azure providers, so you don't have to fear that anything gets missing or so. So you can just switch the API group to the namespaced one, and then you deploy the new XRD and the composition. And you have to put the management policies to observe in these compositions, so we only deploy this on observe state. So when you deploy this and this is synced, then you have 2 managed XRDs and 2 managed resources, and you will see that, sorry, I missed one thing. In the dev repos, you have then also, you deploy it, then you have your XRD and your composition in the cluster, everything is good. Then you go to all your dev repos, and then you copy the claims you have. do a copy of them, add the new API group, and that's it. And then you have a copy of it, and then you wait until it's synced again, and then you should have all your managed resources a duplicate, but an observed state. So, and then comes the third step. This is where, as a third and the fourth, you can combine this. I would combine this. This is then you prepare a PR where you put the management policies from the old compositions in the new compositions, but you only prepare this PR. Don't merge this now or everything gets broke. So just prepare it, and then you go, the third step is happening, you put all your compositions on observe. And then you have like a frozen cluster, frozen reconciliation, so nothing happens then, because all resources are on observe then. And then you merge your prepared PR, because then you have everything ready, you merge it, and then your new XRDs are managing, or your new composite resources namespace then manage the resources. And the old ones are only on observe. And then you can start removing all the old claims from the cluster, from the dev repos, and then you can remove the old XRDs and the compositions. It's a bit complicated. You can, if you want to go, you can just come to the booth. I can explain this a bit better. Yes, and one thing you have to think about is the secrets, because as I showed you on the first, in the claim, you set a secret. Then if you duplicate the claim, you have to set another name. So you have to think about this when you add the secret to your deployments or stateful sets or whatever, that you change the secret. Okay, let's make this short. What broke? Yeah, deleting a claim removes its connection secret. So yeah, we did this. We forgot it to change on a deployment, and then the deployment broke. So you have to think about this. Then there's no push button path. I talked a lot about. So as you see, it's not a push button path. It's slow, but you can reverse. It's reversible at each step, so you can always go back. So nothing really happens. And yeah, what we should, Crossplane 2.3, claims are gone. Tenants use namespace composite resources, and what do we have here? Modern namespace managed resources, XR secrets, app facing. Yeah. And you have to be fast now.
Yes, thank you very much.
This is the last step.
It was so easy to update with all the PRs. Yes, recommendations. As we talked about, design the composite resource definitions as APIs, so don't mirror just the provider config. So this is your product-facing API for the customers or for your app teams. So as Stephan said, small claim, start small. Keep the environment knowledge. What was the environment config out of the developer input? Because they don't need to know that we have the custom Go function, that they don't have to know about the knowledge about the environment. Yeah, so they can just make it a small claim PR or the code. Yeah. Then, as also talked about, that we want to change the default mode from the management policy and remove the delete function, especially for your data-bearing resources. Then we talked also about that the crossplane composition render feature is a unit test in your validation pipelines. Yeah? So always use this mode or this pipeline, how you call it. Yes, then we build dashboards for condition events and so on, observability, clear. And use the custom functions only really when you need it and the complexity pays off, like in our case with this cross-tenant environment setup. But think about if maybe patch or transform is the easier way for your developers. Yeah? And treat V2 as a chance to simplify the platform contract. This you added. What was it?
It's that you remove the claim and then you have everything. So the platform, the resources are then owned by the devs. So you have the namespace composite resource and the managed resources. They are then owned by the devs. Before it was platform owned because it was cluster scope, and only the claim was really owned by the developers.
Okay, perfect. So I think we're finished. We have absolutely no time for questions. So. But we have a booth upstairs with nice coffee.
One slide more.
Oh my god. Oh my god. The goal is not everything is in Crossplane.
Yeah. The goal is a reliable, testable platform. Small input, strong contract, tested output.
Well, okay, thank you.